Okay, hi guys. So we'll be continuing on seeing the reaction of sodium bicarbonate with HCl. So far we have seen the that in the basic medium, Na2CO3 converts itself into NaHCO3. So at first equivalent point, now we'll be discussing the second equivalent point. So let's get started. So at second equivalent point, what will happen is at second equivalent point, complete NaHCO3 gets converted into H2CO3. Gets converted into H2CO3, which is nothing but carbonic acid. Okay, and the reaction goes as follows: that we have NaHCO3 aqueous reacts with HCl aqueous and forms H2CO3 again aqueous plus NaCl. Okay, so here methyl orange would be used as an indicator for this conversion. So we can write that milli equivalent of NaHCO3 would be same as milli equivalent of HCl, okay, at second equivalent point, and as n factor here would again be 1 of both NaCl and NaHCO3. So from here we can derive that millimoles of NaHCO3 indeed would be equal to millimoles of HCl. Okay, and H2CO3 is a weak diprotic acid. Weak diprotic acid. Okay, so in complete titration we use two indicators. This is called double indicator titration. So in the complete titration, first naphthalene was used, wherein Na2CO3 was converted into sodium bicarbonate or NaHCO3, and in the second titration NaHCO3 was converted into carbonic acid or H2CO3, and methyl orange was used in the second step as a indicator. So in complete titration we use two indicators. And this is called double indicator titration. Okay, so if only methyl orange is used, then what will happen is only second equivalent point we will able to capture. Okay, and we would be missing the first equivalent point. Okay, so reaction would directly go from Na2CO3 plus HCl to H2CO3 plus 2NaCl. We'll be directly getting carbonic acid from sodium bicarbonate, and we can directly write that at second equivalent point what will we say, that milli equivalents of Na2CO3 would be equal to milli equivalents of H2CO3. Okay, now here n factor of Na2CO3 would be 2, so we can write in terms of millimoles that millimoles of Na2CO3 multiplied by n factor, which is 2, would be equals to not H2CO3, I beg your pardon, this is HCl. We are titrating Na2CO3 with HCl would be equal to millimoles of HCl, and n factor of HCl would always be 1. Okay, n factor is 1 here. Okay, next let us see that if mixture of NaOH and Na2CO3 reacted with HCl, then what will happen? if mixture of NaOH and Na2CO3 is reacted with HCl, then what will happen is we have a mixture of NaOH and Na2CO3 reacted with HCl. So at first equilibrium point, what will happen is we would get milli equivalent of NaOH plus milli equivalent of Na2CO3 would be equal to milli equivalent of HCl. Obviously here N factor would be used as 1 because Na2CO3 would be getting itself converted into NaHCO3. Okay, so and at second equivalent point what will happen? So at second equivalent point we can say that milli equivalent of NaHCO3. So at second equivalent, let me write what will happen is we would have NaHCO3 aqueous plus HCl aqueous gets converted into terms of methyl orange would be converted into Na2CO3 plus HCl NaCl. Okay, so at second equivalent point what will happen is in the first equivalent point complete equivalents of NaOH will be getting exhausted and NaHCO3 would be formed because of titration of Na2CO3 with HCl at the first equivalent point. So now only NaHCO3 is remaining in the mixture, that's why we are reacting only NaHCO3 remaining in the mixture with NaCl. So at second equivalent point we can say that milli equivalent of NaHCO3 would be equal to milli equivalent of HCl for the second titration or second equivalent point. Okay, so if you have to write this in terms of millimoles, then obviously millimoles of NaOH plus millimoles of Na2CO3, and what would be the N factor here? N factor here would still be 1. Why? Because still the Na2CO3 is getting converted into NaHCO3. Okay, so N factor is still 1, and here you can write millimoles of HCl. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing a question based on the theory which we have discussed still so far. Okay, so till then, good luck and goodbye.